For our physics project, we chose to do two areas of fluid dynamics, siphoning and
capillary action. Let's start with siphoning.
Okay, so we started by taking two containers, filling one with water, and putting it on the deck, and then we took the other container, put it 30 feet away, and on ground level.
our goal was to get the water from point A to point B.
A key component of siphoning is hydrostatic pressure,
which is pressure acting at any point of a non-moving or static fluid. Okay, so the fluid's going to go from the higher container to the lower container is because the hydrostatic pressure of the higher one is greater than that of the lower, and this is all because of gravity.
Think of it as a chain and pulley where the lighter end is shorter and higher, and in turn will be pulled by the heavier lower side, forcing it down. Right there, ready?
We're gonna try this.
Here we go.
But there are two problems with the chain analogy. The first problem is that it's not an actual model of what real siphoning would be like. The second problem is that it factors in weight, which is not a component of siphoning.
So back to our demo.
To get things started, you actually have to get the fluid flowing through the hose.
In most cases, you do this by using suction. And if all works correctly, you should be able to move the liquid from A to B. We wanted to see if we could do it twice.
How many if you see bubbles?
Yeah, there are bubbles.
I did it.
Wait, they don't have to know that.
Understanding this could be useful because there's a lot of applications of siphoning in everyday life. For example, siphoning is common in irrigated fields to transfer a controlled amount of water from one area to another. Large siphons may also be used in municipal waterworks and industry. You can even use self-made siphons to get rid of water in a basement after a flood.
You could also use it to make homemade beer and steal gasoline. If you wanted to, just say. Now here's part 2, capillary action.
Capillary action, also called capillarity, is a phenomena in which liquid spontaneously rises in a narrow space like a thin tube or a porous material like paper.
This effect can cause liquids to flow against the force of gravity. It occurs because of the intermolecular attractive forces and surface tension.
Capillary action is responsible for draining the constantly produced tears from the eyeball.
Paper towels also absorb liquid through capillary action, allowing a fluid to be transferred from a surface to the towel, as you'll see from our demo.
And these are two portions of fluid dynamics that we decided to show you. That's our project.